Welcome to this edition of Buick Know-How, which will focus on the highlights of Buick brake service. Brake service can be a pretty broad topic, so to keep from getting too involved, the program will highlight only the most important points of drum and rotor inspection and resurfacing, drum and disc brake disassembly and reassembly, and special service characteristics of the compact master cylinder and leading trailing drum brake assembly. Let's begin the program with a drum or rotor inspection. There are 4 types of damage you can find with a simple visual inspection. Scoring is the most common damage and usually the easiest to see. Sometimes, though, the friction surface will overheat and leave a bluish discoloration or tiny hairline fractures called heat checks. Occasionally, a drum or rotor will actually crack. Incidentally, if a cracked drum or rotor is found, always replace it with a new one. Never attempt to repair. If the friction surface has only light scoring, you can simply polish it with emery cloth. However, if the drums or rotors have heavy scoring, heat checking, or discoloration, they'll need to be resurfaced or replaced. To determine if the drums or rotors can be resurfaced, they'll need to be measured and checked against specifications. By the way, all needed specifications are listed in the Buick Chassis Manual or this issue of the Know-How Reference Manual. The first measurement determines how much resurfacing can be performed, while the second measurement determines if the drum or rotor is worn out. For drums, these 2 specifications are called the maximum rebore diameter and the discard diameter. The maximum rebore diameter is the maximum dimension to which the drum can be resurfaced. Never resurface a drum more than necessary, but if the drum has heavy scoring or other damage, you can resurface it to the maximum rebore diameter. If damage remains once the maximum rebore diameter is reached, replace the drum. The second specification for drums is the discard diameter. The discard diameter is the maximum dimension to which the drum can be worn. During normal braking, small amounts of metal are worn away from the drum. Normal wear will slowly increase the drum diameter. If the drum eventually reaches the discard diameter, replace it with a new one. Similar to the drum's maximum rebore diameter and discard diameter are the rotor's minimum refinish thickness and discard thickness. The rotor's minimum refinish thickness is the resurfacing limit of the rotor. Like the drum, never resurface a rotor more than necessary. But if needed, you can resurface a rotor to the minimum refinish thickness. If damage remains once the minimum refinish thickness is reached, replace the rotor. Discard thickness is the thinnest the rotor can wear before it must be replaced. As with drum brakes, small portions of metal are worn away from the rotor surface during normal braking. If the rotor eventually reaches the discard thickness, replace it. The discard specification is cast into both the drum and rotor. Remember, this figure is the wear limit. Never resurface to this figure. The remaining drum and rotor measurements check for conditions that are unique to each, but cause similar symptoms in the brake system. Let's look at drum out of round first. When a drum is out of round, the brake shoes will not apply evenly on the drum friction surface. As a result, the driver will likely feel a pulsation through the brake pedal, and the car will likely shudder or vibrate while braking. To determine out of round, simply make 2 diameter measurements at right angles to each other. Next, subtract the smaller measurement from the larger to find the out of round. Compare the out of round to specifications and resurface or replace the drum as necessary. A rotor condition that causes braking pulsations similar to those caused by an out of round drum is rotor thickness variation or parallelism. When rotors vary in thickness, the brake pads will not apply evenly on the rotor, causing brake pedal pulsations, uneven braking, vibrations, and undue strain on brake components. To check a rotor for thickness variation, simply make 4 or more thickness measurements around the rotor. Then subtract the smallest measurement from the largest. Compare the figure to specifications and resurface or replace the rotor as necessary. The final rotor inspection will indicate if the rotor has excessive lateral runout. Lateral runout is a condition that causes the rotor to have a wobbling action while rotating. Because of this wobbling action, brake pads will not apply evenly on the rotor. As you can probably guess, the end result is a pulsation problem. To perform a lateral runout check, mount a dial indicator on the steering knuckle and position the dial indicator stylus approximately 1 inch from the edge of the rotor. Then, rotate the brake rotor, observe the dial indicator, and compare the reading to specifications. If runout is excessive on a hub with integral bearings, check for correct wheel bearing preload. If the preload is correct and the runout is still excessive, resurface or replace the rotor as necessary. Lateral runout can be caused by a loose or damaged bearing assembly, a warped rotor, or on rotors with a separate hub, a dirty or corroded rotor to hub mounting surface. On rotors with a separate hub, excessive lateral runout can often be brought to within specifications by cleaning the rotor to hub mounting surface. If that doesn't work, try indexing the rotor 1 or 2 bolt positions from its original location. If the dial indicator still shows excessive lateral runout, check the hub and bearing assembly for damage. To do this, remove the rotor and mount the dial indicator so the runout of the hub and bearing assembly can be checked. Rotate the hub, observe the dial indicator, and compare the needle deflection to specifications. If the hub and bearing runout is within specifications, but rotor runout was excessive, resurface or replace the rotor as necessary. A good job of resurfacing drums and rotors helps make brake operation quiet and smooth. The following 7 tips will help ensure a good resurfaced finish. Number 1, take a look at the cutting bits. They have to be sharp. A good sharp bit will help make the surface finish as smooth as possible. Number 2, mounting adapters should be free of nicks or other damage. Use of a nicked, dented, or damaged adapter can create taper in drums or lateral runout in rotors. Number 3, when resurfacing, always use a vibration dampener. A vibration dampener makes the resurfacing process quieter and reduces unnecessary vibration that will cause a poor finish. Number 4, check the tool feed and arbor speeds. Correct settings will help produce smooth finishes and reduce brake noise. Number 5, when resurfacing rotors, make sure the same amount of metal is removed from each side of the rotor. Unequal resurfacing can increase the likelihood of rotor warpage. Number 6, once the rotors have been resurfaced, it is recommended that you sand them with a rotary sander. The rotary sander will remove tiny grooves left from resurfacing and will produce a non-directional finish that will reduce brake noise. Number 7, once resurfacing is complete, wash the friction surface of the drums and rotors with denatured alcohol or soap and water. Pay particular attention to the rotors, since improperly cleaned rotors can cause new brake pads to load up with contaminants and cause excessive brake squeal. Now, drum and disc brake disassembly and reassembly. Let's take a look at the important areas of drum brakes first, starting with disassembly. Begin by inspecting the brake shoes. They should be worn relatively even throughout the entire friction surface. If a shoe is not worn evenly, it is likely because of brake hardware problems or a tapered friction surface in the drum. In drum brake assemblies, it is normal for one shoe to wear faster than the other. But remember, if one shoe is worn out, All the shoes on both rear assemblies must be replaced. Also, never reverse the shoes trying to even their wear. Reversing worn shoes can cause the automatic adjuster to fail. If the shoes are glazed or contaminated with grease or brake fluid, replace them. But more importantly, find the source of the contaminant and repair it. Look at the wheel cylinder dust boots for tears, chafing, or cracking. Damaged boots will allow contaminants to reach the piston seal, which can cause the seal to fail. Disassemble the brake unit and look over the brake hardware. Make sure the springs, actuators, gear teeth, retainers, and all other components are in working order. If a piece of brake hardware is questionable, replace it. Now that we've disassembled the drum brake, let's touch base with a few reassembly highlights. Before installing, clean all drum brake hardware in denatured alcohol and clean the backing plate with a damp rag or a special asbestos vacuum. Never brush the backing plate or blow it off with compressed air. The key here is to keep asbestos fibers out of the air. Wheel cylinder bores with nicks, corrosion, scoring, or other damage can be polished with a crocus cloth. If the crocus cloth is unable to remove the damage, replace the wheel cylinder. A piston, on the other hand, can't have any scoring, distortion, wear, or other damage. If it does, it must be replaced. If the piston is free of damage, insert new seals with lips facing inward. Lubricate the piston assembly with .3 brake fluid and install the piston assembly in the wheel cylinder. Finally, use white brake grease to lubricate the contact points of the backing plate and the adjuster screw assembly. When you see grease between the open end of the pilot nut and the socket, the assembly is properly lubricated. Now, on to Caliper Service, starting with disassembly highlights. First, inspect the brake pads for wear. It's common for the outside pad to wear faster than the inside pad. If either pad needs replacing, replace all brake pads in both left and right brake assemblies for that end of the car. Look at the caliper assembly for signs of fluid or grease leaks. As with drum brakes, either of these will contaminate brake pads and must be repaired. Once the caliper is removed, look at the brake caliper dust boot. Check for rips, cracks, or fluid leaking from around the boot. If any damage exists, like the rip in this boot, rebuild the caliper. Once the caliper is removed from the car and disassembled, inspect the piston for nicks, corrosion, or worn chrome plating. If you find a piston with any of this damage, replace it with a new one. Now, inspect the bore of the caliper. The seal groove should be free of damage. The caliper bore may have small nicks or corrosion. If it does, polish the bore with crocus cloth. If the crocus cloth doesn't remove the damage in and around the seal groove, replace the caliper. Here are a few tips that will help assist caliper assembly and installation. You can make piston installation easier by lubricating seals and boots with .3 brake fluid. Then, place the piston on top of the boot and apply 5 pounds of unlubricated air in the fluid inlet hole of the caliper. For best results, simply use a pressure regulator to dial in 5 psi of air. When the low-pressure air inflates the boot, push the piston into the bore. Next, look over the caliper mounting bolts for signs of corrosion. If you find any corrosion, replace the bolts. If the bolts check out okay, lubricate their shaft with silicone grease and put a little silicone grease on the shaft bushings as well. Most models need the clearance between the caliper and bracket stops measured. Correct clearance between these 2 points will allow the caliper to move without binding. Compare your measurement to specifications and, if necessary, file the bracket stops to provide proper clearance and reassemble the caliper. When selecting replacement pads, remember that GM pads are engineered with a specific coefficient of friction. This coefficient of friction provides the quietest braking in the shortest distance possible. Use of aftermarket pads may alter the car's typical braking ability, so always use GM brake pads. To keep brake squeal to an absolute minimum, some pad compositions have been changed. Look at the dealer service bulletins to see if changes have been made for the car you are servicing. The final point to remember when installing pads is that some pads are held in place by clinching them to the caliper body. The best way to clinch pads is to first seat them by applying and releasing the brake pedal a few times. Then have an assistant hold the brake pedal down while you bend the tabs against the caliper body. The leading trailing drum brake assembly and the compact master cylinder are two relatively new brake components. Let's look at the compact master cylinder first. The compact master cylinder is very similar to and operates generally the same as the other traditional Buick master cylinders. It does, however, have a couple of minor differences. To remove the fluid reservoir, 2 hold-down pins must first be removed. Simply drive the pins out with a hammer and a punch. When you've removed the pins, pull the plastic reservoir off the aluminum base. To reinstall the reservoir, lubricate and position the rubber O-rings. Push the reservoir straight down into the master cylinder base and drive the hold-down pins back into position. The compact master cylinder is also the first Buick master cylinder to have serviceable proportioning valves in the base of the master cylinder. Remember, proportioning valves reduce the possibility of rear wheel lockup by limiting fluid pressure to the rear brakes. Under light braking, pressure to all brake assemblies remains relatively equal. But when the brakes are applied with moderate to heavy pressure, the proportioning valve directs the additional fluid pressure to the front brakes. Servicing these proportioning valves is very similar to servicing the regular master cylinder pistons and cylinder bore. To get at the valves, remove the fluid reservoir and unscrew the proportioning valve caps. Then carefully remove the pistons from within the bore. The bore should be free of scoring, nicks, corrosion, or other damage. If the bore is damaged in any way, replace the master cylinder. Never attempt to polish the bore. Inspect the proportioning valve pistons for scoring, distortion, and wear. If a proportioning valve piston is damaged, replace it. When reassembling the proportioner valve assembly, be sure to install piston seals with the lips facing upward and lubricate with .3 brake fluid. Once all seals are lubricated, return the piston and spring to the bore and screw the proportioning valve caps back into place. The other relatively new brake component is the leading trailing drum brake assembly, which is serviced similarly to other Buick drum brake assemblies. Here are a few of the differences. First of all, the leading trailing unit is the only Buick drum brake assembly to have the shoes held stationary at the bottom of the backing plate. As the brakes are applied, the leading shoe comes in contact with the spinning drum and is self-energized as the drum pushes it against the stationary anchor plate. The trailing shoe applies some braking force but does not self-energize. Because of this, the leading shoe applies the majority of the braking force. The leading trailing brake drum is removed differently than any other Buick brake drum. Without knowing the procedures, you probably won't be able to get the drum off the car. Begin by making sure the parking brake has been released. Loosen the parking brake cable at the parking brake adjuster beneath the car and remove the rubber access plug located at the rear of the wheel spindle. Insert a screwdriver and push forward against the parking brake lever until you hear it click. Then, use the screwdriver to push the parking brake arm rearward. Next, break the drum loose by inserting a steel punch in the hole at the bottom of the splash shield and hit the punch with a hammer. Now, tap the drum on the outer rim or around the inner drum diameter by the spindle. When the drum is loose, remove it. Now that the drum is off, you'll see the inner components of the leading trailing brake drum assembly. One unique component is the bimetallic clip. The bimetallic clip is installed to prevent the self-adjusting mechanism from over-adjusting when the brake drum becomes hot and expands. Look the bimetallic clip over and make sure it's not warped, broken, or damaged in any way. If any damage is found, replace it with a new one. Near the bimetallic clip is an adjusting screw that requires specific attention during reassembly. It's important that the self-adjuster screw be installed with its shorter fork on the outside face of the brake shoe web. When the self-adjuster screw is installed properly, the adjuster actuator will fit in a notch between the brake shoe web and the self-adjuster screw. When the remainder of the assembly is put together, give it a once-over to make sure the shoes are seated properly. With the leading trailing drum brake assembly, it is important that you properly adjust the parking brake. If the parking brake is not adjusted correctly, service brake operation will be affected. Begin by adjusting brake shoes so the drums will just fit. Then, with the drums in place, complete adjustment by pushing the service brake pedal 30 to 35 times, pausing 1 second between applications. Next, apply the parking brake until it clicks 10 times, then release the parking brake. Repeat application and release 5 more times and make sure the parking brake is released. Take the drum back off, go to the access hole, remove the plug, and adjust the parking brake cable so an 1/8" drill bit will fit between the parking brake arm and the brake shoe web. The parking brake is adjusted correctly when the 1/8" drill bit will fit between the adjuster arm and the web, but a 3/16" drill bit will not. Put the drum and wheel back into position and check for wheel rotation and normal braking. As with any brake job, complete the repair by road testing the vehicle. Apply the brakes in varying conditions to make sure the repair you have made is the best it can be.